if you have worked as an engineer with energy, then of course the two main units, like the watt and the watt hour, or the kilowatt and the kilowatt hour, is you know what it means. We have the capacity, like when you look at an electric equipment like your hairdryer, it has a nameplate, and the nameplate capacity, what we call it, would perhaps be 1000 watt. Yeah? Or on your toaster, or whatever you have at home, and you can look it up on the bottom. There is a sticker which is the nameplate and says 1000 watt. And this is like the capacity it will pull from the grid at the moment. And when you then use your toaster for 1 hour, you would never do that, because then you will get very burnt toasts. But if you use it for 1 hour, the 1000 watt is also 1 kilowatt. So we have this kilo and then mega and so on to increase the size of the capacity. So if you use it for 1 hour, your toaster or your hairdryer, which is also not so recommendable thing to do it, then you will have used 1 kilowatt hour. And that's the usual unit which you also will find on your electricity bill. Or when you look at your electricity meter in your house, it will show you kilowatt hours. And yesterday we talked a little bit about how much does a household consume over the year. And when you remember the slide with the building regulations, part L, 200 kilowatt hours per square meter per year is like the old standard. That would mean if we have a 100 square meter house, you would use 200 times 100 is how much? Yeah, 20,000. It's 20,000 kilowatt hours per year. That would be the average household use for a small family home per year. And 20 kilowatt hours, as we say, kilowatt and megawatt is like times 1,000. That would be then 20 megawatt hours. Yeah? And so on. If you multiply this by 1,000 households, then you have 20,000 megawatt hours or 20 gigawatt hours. So megawatt hours. And then again, the next size is gigawatt hours. And then when we talk about the country's electricity consumption, I think the whole Ireland country, what is it, about 34, I think, when I remember correctly, terawatt hours, what the country consumes. Then we have terawatt hours. So kilo, mega, giga, tera, and it's always a factor 1,000 in between. I think that's very...
The 200, is that 200 meters square?
200 kilowatt hours per square meter per year.
Per square meter.
Yeah. So that's according to the building regulations, like from 1990. But today, the standard prescribes something between 40 and 50. Yeah. And the 100 was like the square meter size of the building, which I assumed for a smaller house. And then, of course, so this is like the fact when you have a heater installed to heat your house, you would have perhaps a 10 kilowatt heater. That means 10 times as strong capacity or strong effect as your toaster. That would be sufficient to heat your house. Depends, of course, on the climate, depending on the building envelope, depending on the, as we talked yesterday, on the people living in the house. If you have elderly people in the house, they usually need higher temperatures. So that is just like a ballpark figure. But 10 kilowatt to 15 kilowatt is the usual size of a heater in a family home. Yeah, we have done that, the energy units. And then in statistics, you will find very strange other units as well, which are kilotons of oil equivalent, or gigajoule, or what is it, British thermal unit. And those are usually used when you talk about heating and fossil fuels. So when you find statistics, but sometimes I also saw in the is it CSO, the Irish Statistical Organization, they also use kilotons of oil equivalent to present electricity consumption data there, which is a little bit weird. But there are conversion factors if you want to know them in terawatt hours, which is more used usually in the electricity sector. It's easy to convert it. But these are the energy units which EnergyPLAN uses, and I think we stick to them for today. Again, capacity, watt or kilowatt or megawatt. If you have a hydropower station, a smaller one has perhaps 1 megawatt, or a mid-size 10 megawatts of hydropower station. And a nuclear power station can have up to 1 gigawatt or even more of electricity capacity. That doesn't necessarily mean that they produce to that maximum all the time, depending on the water flow in the hydropower station and depending on other reasons in fossil-fired. But that's the maximum power, like on the nameplate. Okay, back to our reference energy system. We have discussed the demand side, which is important because it drives our electricity supply as well. And we want to make sure that future supplies are more sustainable, produce less environmental impact, produce less harm on our atmosphere. Yeah. Again, the workflow in EnergyPLAN, we have to have some input data to get going. Yeah? We have seen yesterday, as you have created the reference energy systems, that there is information out there. People know already much of what we need. But of course, we will find out that we have gaps, and then we need to make sure to fill these gaps with data, which are perhaps assumptions, because we don't get the exact data in many cases. But the assumptions in most cases, of course, can be justified by using like standard rules, like as we discussed, the kilowatt hours per square meter per year, for example, can be assumed. You know the buildings, most of your buildings, for example, when we talk about building heating demand, are in your village older than 50 years and have never been renovated, then we can assume they might use 200 to 250 kilowatt hours per square meter per year. Or if there are new commercial buildings, we have to apply the building standards. This is what we know. If you have access to measured data, even better, then you can use them, of course. But assumptions are good for a beginning, and if you justify your assumptions, I think we can get into a range which is valid, and the model will reflect reality in sufficient quality. Then we feed all into EnergyPLAN and run and see the results and do some analysis, and then start thinking about what scenarios are feasible for our case, starting from energy efficiency or implementing renewable energy supplies, which replaces imports or replaces gas and coal-fired power plants. So now on the screen on the left-hand side, you see the content of the zip file which I sent you, which has the structure, 3 folders, cost and data and distributions. And then on the right-hand side, you have the structure from when you have installed EnergyPLAN. You will have EnergyPLAN/data, EnergyPLAN/help, EnergyPLAN/tools. And when you go into EnergyPLAN data, you will have the same structure as in the zip file. Yeah. Don't delete the EnergyPLAN file, but you copy the new files into the EnergyPLAN folders. I'm not sure what the EnergyPLAN cost, the original folder includes. So I have a lot of data there, which is from my cases. But what you have in your cost folder, these are the cost database which EnergyPLAN delivers. Since last year, they only deliver an Excel file. They don't deliver this text file anymore. Yeah, so these cost text files we have created, and we have made it available for the years 2015, 2020, 2030, 2040, and for different currencies. But in Ireland we use euro. So these 4 files with the euros, you copy them into the cost folder from EnergyPLAN. So in the cost folder, you should have these 4 files, at least these 4 files with 2015, 2013, 40, and the euros. So when you open the EnergyPLAN data distributions folder, you will find a lot of distributions there. EnergyPLAN usually keeps like all the files which have been created from different projects and have been submitted to the university. They are made available there. So also on the EnergyPLAN website, you will find a lot of case studies where you can download data from Croatia, from Sweden, even from Ireland. There is a case study done in 2009, I think, a bit old data, but still perhaps useful. Yeah. But for now, we have created this data for our case, and these distribution files should be now in the right folder. Okay? We mentioned a few times these distribution profiles, or which EnergyPLAN needs to understand how the consumption of energy, the demand and also the supply, is distributed over the year. So what we enter into as input into EnergyPLAN are usually these annual demands, which are gigawatt hours or megawatt hours or something like that. It's one big figure, like energy demand of a village or a country. And then we need to add and choose a distribution profile, which actually tells us over the whole year in our hourly time slices, as 8,784 time steps, how this annual demand of, let's say, 3,250, just a figure, how this is distributed over the year. That means we have, for example, for heating, we would have higher demand during the January-February period, then it goes down, and then we have higher demand again when the cold period starts. And this distribution file, for example, for heating, we get the temperature data, and we had converted this into heating degree days, which is a conversion of the temperature data and is used to decide how much energy is actually used for heating. Okay? We will have a look at one or two examples of the distribution files so that you see how EnergyPLAN can be used to have a look at these files. Okay, now we are ready to open EnergyPLAN. You are in your folder where you have installed EnergyPLAN, and then you have this executable 140 or 142, depending on which version you got to download. Anyhow, if you start this, it will start and put you on the home screen, and it will start with an initial data set, which they call start data. And when you just open demand electricity, you will find some data already preset, which we don't really need because it's an example of one of the exercises. So one possibility is to go through and set zeros everywhere, but I have done this work for you, and now you can go into open and find your start data, Ireland, Athlon 0, and open that. If you get error messages now, that would mean that you haven't put the files into the right folder. No, but that's okay. I think we will fix the error together, yeah, because that will also teach us how to use it. It's a good training. Let's start from scratch. These distribution profiles, we want perhaps have a quick look on how they look like. EnergyPLAN comes with some extra tools. On the upper menu, you have add-on tools here, and there is a tool called Edit Distribution. If you open that,
Sorry, is that under supply?
no, it's on the menu on top, add-on tools, and there is a tool called Edit Distribution. Then you can click on Load File and scroll to find these files which have the name IE, like for Ireland, underline hour, etc. And then you can, for example, load this HDD 17 hot water, HDD 17 HW. So I have opened now this heating degree day file, which is determining how much heating energy is used over the year. So this is just to visualize this distribution profile, so you get an idea how they look like and how, in case of Athlon, for example, how the heating distribution would look like over the year. Of course, as usual, we have the early months in the year, and then later in the year, heating demand is increasing. And this heating degree day file, which I have created, is also adjusted, which includes hot water demand. Otherwise, it only includes heating demand. So you see this adjustment by this constant added here in the bottom. It doesn't go down to zero. So that means heating demand is, hot water demand is included here in the heating demand. If we don't do that, then we will only have the heating demand. And EnergyPLAN has no possibility to distinguish between heating and hot water demand. So we have to put all heating demand, including hot water, into one file. Yeah? So this is one example of distribution profiles. Another one which we are using is, for example, this one, the demand megawatt from the grid, which Christoph helped us to put together. And this is actually how the whole country consumes electricity over the year, the electricity demand of the whole country. And perhaps one note to make is also the distribution profile. The numbers here do not really matter, because EnergyPLAN normalizes these figures internally. So if you have a distribution profile for electricity consumption for the whole country, you can still apply it and use it in your local site. And then you have at least a starting point where you can start off with your model. Of course, to get a more specific site data would be great if you can get it, if you have a local distribution utility and you contact them and ask them, is this possible to get? I don't know if there is any public data available on that. I don't think so, usually not. I think in LECO, for the LECO project, we will help you to get this data as much as we can. Because usually, if you can get them, you get them in an Excel format, and then you have to convert it into the EnergyPLAN format.
So are these data files available to download from AirGrid?
Not in this format. Yeah, they're a bit complicated to get, and then you put them yourself into Excel format, and then you have to still convert it into EnergyPLAN format. Okay. I think for the LECO communities, we should as a starting point, we use the national data, at least for electricity consumption profile. And if we have a chance to get local electricity consumption profiles from the local utility, then we would use them. But these files are public domain. Yeah? So they are actually available in the public domain, but not in the format we need them. And we have converted at least what we have now. And if we need more site-specific data, we can try to get them. If we get them, fine. If not, we still have to use national data.